Okay, next lesson is very similar to our previous lesson. We are going to be graphing exponential decay functions this time. So instead of growth, we're going to be focusing on decay functions, which, as the name kind of suggests, just means that the function's getting smaller rather than bigger. So this is kind of how our parent function looks. Again, as our graph is moving to the left, it's increasing, and as our graph is moving to the right, it's decreasing. We still have that asymptote at x equals 0 as a part of our parent function. The domain is all real numbers, which means left or right, there's no holes. However, the range, the y values, are all going to be greater than 0. So if we get into an example, y equals 1/2 x. Again, I recommend you make a table, get some x values, get some y values. Plug them in, find out what you get. 1/2 to the -3. So again, y equals 1/2 to the -3. That's like saying, all right, I need to invert this. That's like saying 2 to the 3/1, which is going to give me 8, 4, 2, 1, 1/2, 1/4. So again, when we end up graphing that, start up here, 1, 2, 3, 4. See here, -1 is 2, 0 is 1, 1 is 1/2, 1/4, 1/8. It's going to keep getting closer and closer to 0 without ever touching. It is good to label some of these points. So I'd call this 0, 1. I'd call this -3, 8. It's good to label those so that you can be exactly clear on what you're trying to do. Again, very similar to last lesson. Again, these two lessons are very related to each other. If we have this as our base function, again, we've got two things to focus on. This is going to move it horizontally, and this plus or minus will move it vertically. So as I take a look, if I try to graph the function, let's say we want to graph y equals 2 times 1/4 x. And then we're also going to do y equals -3, 2/5 to the x. So again, I always say that probably some of the easier numbers to plug in are x is 0 and x is 1. This will give you a generic idea. You may want to plug in, a -2 and a +2, or a -5 and a +5, just to help yourself out. But if 1/4 to the 0 power is 1, that means x is going to be 2. And when I plug in a 1 here, 2 times 1/4 is 2/4, which simplified gives us a 1/2. So as I'm thinking about this graph, I know that when x is 0, y is 2. When x is 1, y is 1/2. So I would go ahead and, oops, I totally missed there. Again, it's not very good on my part. But I would label it 0, 2, 1, and 1/2. And again, you get the general idea that it's increasing to the left and decreasing when it goes to the right. Looking at this one, I would say, all right, if I plug in a 0 here, I get -3. If I plug in a 1 here, I'm going to get -6/5. So as I'm graphing this one, x is 0, y is -3. X is 1, y is -6/5. So my graph is going to look something like this: 0, -3. 1, -6/5. Okay, graph the following equation and state the domain and range. So if we are trying to graph y equals 3 times 1/2 x plus 1 minus 2. So again, I'll start by graphing my parent function. All right, so the parent function would just be y equals 3 times 1/2 to the x. So again, if I were to graph that, when x is 0, y is 3, and when x is 1, y is 3/2, or 1/2. So my generic kind of parent function for this equation is going to be that. Now I'm going to graph this one. So, maybe I should have wrote this in a different color. Let's see, can we change it maybe? Style, yeah, there we go. All right, so now we're gonna use blue here. So I'm going to translate this, again, highlighting x plus 1. This is the one where it's backwards. Because our base formula is x minus, the only way to get plus is x minus a negative. So because it's plus 1, it's really x minus -1, which means we have to move it to the left. So I'm going to move this left 1, and I'm going to move it down 2. So every point's going to go left 1, down 2. I'm going to go left 1, down 2. So now when I graph my new function, I'm going to have this, okay, this is this function right here. Let's label our points. So I'm going to call this -1, 1, and then this is 0, -1/2. And then my domain, again, there's no holes on the left or the right, so it's all reals. However, I do have an asymptote. My asymptote originally was x equals 0. After moving it down 2 units, it is going to be y is greater than -2. So again, totally missed. I'm off today. My asymptote would be right here. My line will never cross that. All right, so very similar to last lesson, we had the exponential growth and we used like compound interest. Well, we can also have an exponential decay model. This, I guess, can be done. It can be about decreasing value. So like maybe you buy an asset and it decreases in value. Oftentimes the best example of that is a car. They say that as soon as you drive the car off the lot, it starts losing money. It could also be like a bacteria is decreasing by half every time, or something is, the rainforest is losing its volume by 1/3 every 10 years, something like that. So there are kind of a lot of real world examples where this can happen. Similar though, this is our initial amount, our A value. Our R is our rate. And then T stands for time. So let's take the example of a snowmobile. So a new snowmobile costs $4,200. The value decreases 10% each year. So let's write an exponential decay model and then estimate the value after 3 years. So if this is our base function, the 3 things I got to consider is A, R, and T. So I know that my initial value was 4,200. Okay, my initial value is 4,200. My rate is 10%, but again, we have to convert that to a decimal, so that's 0.1. So my rate is 1 minus 0.1, and then to the T, so this would be 4,200, 0.9 T. That would be my function. Now, the question said, what is the value after 3 years? Well, all I have to do that is plug in 3 for T and calculate it. Again, please use a calculator. So after about 3 years, you would approximately lose, what is that? $1,150. So not great, but again, hopefully you got a lot of enjoyment and you rode that motorcycle or that snowmobile a lot. So now we can graph it. So if I were to draw this up, do something like this, okay, 0, 2, 4, 6, 8, let's call it 1,000, 2,000, 3,000, and 4K. We started just above 4K, $4,200. After 1 year, after 3 years, it was 3,061. So again, I need at least 2 points. You don't necessarily only need 3 points. If you wanted to get a better picture, you could try to do something like that. So again, if I were to estimate, this would be roughly year 1, year 2, year 3, year 4, year 5, year 6, okay, ... So if I said use the graph to estimate what it would be about 5 years, well, this is my 5-year mark. I'm going to estimate. Again, it's just an estimate. I would say that estimated after 5 years, that would be about $2,500. So if you tried to resell it after 5 years, you could estimate that you'd get about $2,500.